Welcome back, everyone. Today we are going to be using Cramers Rule in order to solve the following system of equations. So let's get into it. All right, the first thing I'm going to do here is I'm going to rewrite the system of equations in an augmented matrix form. So I'm just going to write down all the different coefficients that we have on our left and all my constants on the right. So in terms of our coefficients for the first equation, it's going to be 2, 1, negative 1. And then our constant on the right that we have is 3. Then for the second equation, we have 3, negative 2, 4, and 7. Then 1, 3, negative 2, negative 1, like that. Now I need to actually find the determinant of matrix A and then of the determinant of matrix AX, AY, and AZ. So before I do that, I want to be clear what I mean by determinant of matrix A, what I mean by matrix AX, a matrix AY, matrix AZ. So let's get into it. Okay, so for matrix A, that is just going to be all of these values that we have over here. So I'm just going to copy these down without the constant. So 2, 1, negative 1, 3, negative 2, 4, and 1, 3, negative 2, like that. Then for matrix AX, what I'm going to do is I'm going to write down this same matrix, except that the X column is going to be replaced with the right side with 3, 7, negative 1. So instead of this column here, which above was 2, 3, 1, it's now going to be 3, 7, negative 1. And then the other columns are the same as before. So 1, negative 2, 3, and negative 1, 4, negative 2. Same thing for matrix AY. Matrix AY is going to be where we take this, this same matrix here, matrix A, but instead of putting row Y just as it is, right, the second row, we're going to replace it with the constants, okay? So in the middle row, we're going to have 3, 7, negative 1, and then on either other side, we're just going to copy down the columns from matrix A. So let's see here, 2, 3, 1, negative 1, 4, negative 2, like that. And then same thing with AZ as well. We're going to be replacing that third column. I think I might have said row before, but I keep meaning I mean column. The third column here with the constant column, which is 3, 7, negative 1. And then for the other ones, for the X column and the Y column, I'm just going to rewrite what we have here. So that's how we find these matrices. And now all we have to do really at this point, now that we've written out all these matrices, is we need to find out what the determinant of all of these are. Because if we knew the determinant for all these matrices, we could very easily find X, Y, and Z just by using a simple fraction equation, just simple division. Okay, so let's start with the determinant of the first matrix, determinant of matrix A. I'll briefly review how to find the determinant of a 3 by 3 matrix here, but if you want a more detailed video on that, I do have one of those as well, just specifically going over the determinant of a 3 by 3 matrix as the main topic. All right, so determinant A is going to be 2 times negative 2 times negative 2, which would be 4 minus 4 times 3, which is 12. And then next we do minus the second one, so minus 1 times 3 times negative 2, so negative 6, minus 4 times 1, which is 4, and then plus negative 1 times 3 times 3 is 9, minus negative 2 times 1, which is negative 2, so minus negative 2 there. So let's just simplify that then. That's going to be 2 times negative 8 minus 1 times negative 10 minus 1 times 11, which is going to be equal to negative 16 plus 10 minus 11, which is the same as, let's see, well, that's the same as negative 16 minus just one more, so negative 17. Okay, now let's also find a determinant for ax, ay, and az. Okay, so a determinant for ax is going to be equal to 3, so first entry, times negative 2 times negative 2, which is 4, minus 4 times 3, 12, minus 1, so second entry there, times 7 times negative 2, so negative 14, and then minus 4 times negative 1, so minus negative 4, and then minus 1 times 7 times 3, which is 21, minus positive 2, right? Because minus negative 2 times negative 1 would be positive 2. So minus just regular 2. Oh. And then we have 3 times negative 8 minus 1 times negative 10 minus 1 times 19, which is going to be equal to negative 24 plus 10 minus 19. And let's see, negative 24 minus 19 is negative 43, plus 10 would just be negative 33, like that. Okay, next let's do the determinant for ay. So determinant of ay, so same kind of idea here. We're going to do 2 times 7 times negative 2, which is negative 14, minus negative 4, minus 3 times negative 6 minus 4, minus 1 times negative 3 minus 7. So that's going to be equal to 2 times negative 10 minus 3 times negative 10 minus 1 times negative 10. A lot of negative 10s here. That's going to be negative 20 plus 30 plus 10, which is 40 minus 20, which is 20. So determinant for ay is 20. And then last but not least, determinant of az. Okay, so that one we're going to have 2 times, let's see, negative 2 times negative 1 is 2. 2 minus 7 times 3, 21, minus 1 times 3 times negative 1, negative 3, minus 1 times 7, 7, plus 3 times 3 times 3 is 9, minus negative 2 times 1, which is negative 2, like that. So then we're going to get 2 times negative 19, minus 1 times negative 10, plus 3 times 11. So that's going to be negative 38. Yeah, negative 38 plus 10 plus 33. So that's going to be the same as 43 minus 38. And that is going to be 5. Okay, so in conclusion, so what's the answer then? After all this work, what's the answer? I promise we're very close to the answer. For x, we know that it's determinant ax over determinant a. So therefore, the answer for x, there's not a lot of room here left, I guess, but I'll just, I'm going to move this and I'm going to write the final answers here. Okay, so x is equal to determinant ax over determinant x. So that's going to be negative 33 over negative 17, which is just 33 over 17. So that's the final answer for x. For y, same idea here. It's going to be determinant of ay over determinant a. So that's going to be negative 20 over 17. And then for z, same idea here. It's going to be the negative version of 5 over 17, just by using what we found and then using these equations here. So really, once we found the determinants, we've done pretty much everything. We can just use a simple division equation to figure out the rest using Cramers rule. All right, as always, if you have any questions, please leave those down in the comment section, and we'll see you for the next one.